Okay, now we discuss some problems. First problem is calculate the total vapor pressure of a solution having 10 gram of carbon tetrachloride CCl4 and 15 gram of SnCl4. The individual vapor pressure of pure CCl4 and SnCl4 at 25 degrees Celsius are 115 and 238 torr respectively. Okay, so here molar mass of CCl4 because we need to calculate mole fraction. In order to calculate mole fraction of each component, we need to first calculate number of moles of each component. So weight of each component is given. So we need to calculate. We need to first know the molar mass of the components CCl4 and SnCl4. So molar mass of CCl4 is 154 grams mole inverse, and molar mass of SnCl4 is 170 grams mole inverse, right. So number of moles of CCl4 if we say this is N CCl4, if we consider this is as N CCl4 is 10 by 154, and number of moles of SnCl4, if we consider this as N SnCl4 is 15 by 170. So total number of moles if we consider this as N is N CCl4 plus N SnCl4, so 10 by 154 plus 15 by 170. Now we need to calculate mole fraction. So the mole fraction of CCl4 if we consider this as X CCl4 is N CCl4 by total number of moles N. So we write 10 by 154 by 10 by 154 plus 15 by 170. Similarly, mole fraction of SnCl4, consider this as X SnCl4 is N SnCl4 by total number of moles N. So we write 15 by 170 by 10 by 154 plus 15 by 170. Right. Now given the individual vapor pressures of pure CCl4. So given P naught CCl4, this is vapor pressure of pure CCl4, this is vapor pressure of pure CCl4, is 115 torr, and P naught SnCl4 is 238 torr. So P naught SnCl4 is vapor pressure of pure SnCl4. And we know P A is P naught A times X A, right. So P CCl4, so partial pressure of CCl4 in the solution. So PCCl4 is the partial pressure of CCl4 in solution is P naught CCl4 times X CCl4. And if you calculate this one, we get 48. Okay, so this is this is 48.76 torr. And P essential 4 is P naught essential 4 times X essential 4. So again here P essential 4 is the partial pressure of essential 4 in solution. And if we calculate this one, we get 185.85 torr. But we need to calculate total vapor pressure, right? So total vapor pressure. So total vapor pressure of the solution is, if we consider P is P CCl4 plus P essential 4. And then we already got the values of P CCl4 and P essential 4. So if we substitute, we put 48.76 plus 185.85, and if we add them, we get we got this one, we got not 185, we got this one is 137.08. So if we add them, we get this is 138.08. So if we add them, we get 184.84 torr. So this is the answer. Next, we move to problem number 2. It says calculate the partial pressure and total vapor pressure of an ideal solution of benzene and toluene. The pure vapor pressure of benzene and toluene are 184 torr and 60 torr respectively. Also find the mole fraction of benzene in vapor above the solution that has 0.4 mole fraction of benzene. So X benzene, X is mole fraction of benzene, is 0.4, and mole fraction of toluene since total mole fraction is 1, so mole fraction of benzene plus mole fraction of toluene gives you 1, so mole fraction of toluene will be 1 minus 0.4, so 0.6. Now, for pure components, vapor pressures are given. Okay, so the vapor pressure of pure benzene is 184 torr. So So, vapor pressure of pure benzene, if we say this one as P1, if we say this one as P not benzene is 184 torr, and the vapor pressure of pure toluene, so this is P not toluene is 60 torr, right. Okay. So, we need to calculate total vapor pressure. So, in order to calculate total vapor pressure, like the previous problem, we need to calculate P benzene and P toluene. So, the partial vapor pressure of benzene is P benzene is partial mole fraction of toluene, this one. So, P benzene is X benzene times P naught benzene. So, we get we can calculate this one as, so mole fraction of benzene is 0.4 and P naught benzene is 184. So, it gives you 73.6 torr. Similarly, the partial vapor pressure of toluene if we say this is P toluene is X toluene times P naught toluene, 0.6 times 60, so get 36 torr. So, the total vapor pressure of the solution P is P benzene plus P toluene. So, if we substitute, P benzene is 73.6 and P toluene is 36. So, we get 109.6 torr. Now, we have to also find the mole fraction of benzene in the vapor phase. Okay. So, the mole fraction of benzene in the vapor phase if we say P benzene, sorry, X benzene in vapor phase, this is P benzene by total pressure, right. So, P benzene is 73.6 and total pressure is 109.6. This is torr again and this is torr. So, we get 0.671. So, this is the mole fraction of benzene in the vapor phase. Next, we move to problem number 3. It says two liquids behave as an ideal solution. At 60 degrees Celsius, the total vapor pressure of the solution having 1 mole of A and 2 moles of B is 300 torr. When 1 mole of A gets added, the new total pressure becomes 400 torr. Calculate the pure vapor pressures of component A and B. So, here initially we had total number of 3 moles, right, 1 moles of A and 2 moles of B, and total pressure was 300 torr, but later we added 1 mole of add again. So, So now we have total 4 moles of total number of moles is 4, having 2 moles of A and 2 moles of B, and the new total vapor pressure is 400 torr. Okay, so we need to calculate the pure vapor pressure of A and B. Okay, so we consider. Okay, let us consider the vapor pressure of pure component A is PA naught, and the vapor pressure of pure component B is PB naught, right. Now, initially in A is 1, in B is 2. Na is the number of moles of component A, number of moles of component A, and in B is the number of moles of component B. So, XA means mole fraction of A, is 1 by 1 plus 2, so we get 1 by 3, and XB we get 2 by 1 plus 2, so we get 2 by 3. So, here XB is the mole fraction of component B. Now, PA, in the first case, PA is partial vapor pressure of component A is XA times PA naught, so we get 1 by 3 times PA naught, and PB is the partial vapor pressure of component B. We write XB times PB naught, so we get 2 by 3 times PB naught, and PA plus PB is total vapor pressure equals to 300 torr. So, we write 1 by 3 PA naught, because PA is 1 by 3 PA naught and PB is 2 by 3 PB naught, gives 300. So if we further simplify, we get PA naught plus 2 PB naught is 900. This is equation 1. When 1 mole of A is added, then XB, we say XB prime here, XA prime is the mole fraction. Now, after adding 1 mole of component A, then mole fraction of component A, if we say XA prime, is now total number of moles of A is 2. Initially we had 1, we are adding 1 more, and total number of moles we had 3, now we had another 1 mole, so 4. So 2 by 4, so we get 1 by 2, and xb prime is the number of moles of mole fraction of component B after adding 1 mole of component A. Here also we get 2 by 4, so we get 1 by 2. Okay, so the new vapor pressure is 400, so we get 1 by 2 times Pa naught plus 1 by 2 times Pb naught gives 400. So you get Pa naught plus Pb naught is 800, and this is our equation 2. So if we solve equation 1 and 2, we get basically if we subtract 1 minus 2, so we subtracting 1 minus 2, we get Pb naught is, or 3 Pb naught, 2 Pb naught minus Pb naught gives 900 minus 800, so we get 100. So Pb naught is 100, okay, and Pa naught will be, if we consider this equation, so Pa naught is 800 minus Pb naught, so 800 minus 100, we get 700. So Pb naught is 100 torr, and Pb naught B is 100 torr, and Pa naught is 700 torr. Next, move to problem number 4. It says pure vapor pressure of components A and B of a solution are 200 and 500 torr respectively at 30 degrees Celsius. Calculate the mole fraction in the vapor and liquid phases, given that the total vapor pressure is 350 torr. Okay, so we need to calculate number of moles of A and B in the solution, or mole fraction of A and B in the solutions. Okay, so we consider the mole fraction, of component A is Xa. Therefore, the mole fraction of component B in the solution, component A in the solution. So, the mole fraction of component B in the solution, therefore, the mole fraction of component B in the solution is considered Xb. Xb is 1 minus Xa, because total mole fraction is 1. We have binary system, 2 component system, right, and given the vapor pressure of pure component A is 200 torr, and if we say this is a pure component A, if we say this one is Pa naught is 200 torr, and the vapor pressure of pure component B is, we say this is Pb naught is 500 torr. Then Pa is 200 times XA and PB is 500 times 1 minus XA. So, total vapor pressure P is PA plus PB, and the value of P is given 350, and PA is also we calculated 200 times XA plus 500 times 1 minus XA. Okay, so if we simplify this one, we get 350 is 200 XA plus 500 minus 500 XA, right. So, we get 300 XA is 500 minus 350, so gives you 150. So, XA is 150 by 300, so we get 1 by 2 is 0.5. Okay, so XB will be 1 minus 0.5, so you get also 0.5. So, XA and XB are the mole fraction of component A and B in solution, okay. But in the vapor phase also we need to calculate the mole fractions of A and B, okay. So, the mole fraction of A in the vapor phase if we say this is XA vapor is PA by P. So, value of PA, so value of PA is 200 times XA, XA is 0.5 by P, P is 350. So, 100 by 35, 350. So, we get 2 by 7, and the mole fraction of B in the vapor phase if we say this is XB vapor is PB by P. Now, the value of PB is 500 times 1 minus XA. So, it is your again 500 times XB is 0.5 by P. P is 350. So, you get 250 by 350. So, you get 5 by 7. Okay.